So today we'll start with the mole. So what is mole? So as we all know, mole is nothing but that is going to be defined as a substance
A substance which contains Avogadro number of entities.
yes, which contains Avogadro number of entities. Yes. So this is what we define as a mole. So we know what is Avogadro number, right? So we know Avogadro number is equal to
0.23 into 2 to 10 to the power of 23.
yes, 6.022, or you can take 0.23 to 10 raised to 10. Yes. So that's Avogadro's number. Okay. So what exactly a mole means? So agar correct agi mole andre ಏನು ಅಂತ ನಾವು define ಮಾಡಬೇಕಂದ್ರೆ, so we know what is 1 dozen is equal to how much?
12.
12.
Right? Yes. So if I am buying 1 dozen of apple, how much apples I will be having? If I am buying 1 dozen of apples, how much apples I will be having?
12 apples.
12 apples, right?
Apples.
Yes. Similarly, if I buy 1 dozen of books or pens or pencils, whatever. But what is happening here? Wait. So if I am buying 1 dozen of apples, buying books, buying pens, or if I have 1 dozen of pencil, so it all means that are equal to 12, right? So it might be 1 dozen of apple, it might be books, pens, pencil, whatever. All that are equal to 12 units. Do you agree?
Yes, sir.
Okay. So in this case, what is remaining constant?
One dozen.
Yeah, right. So the word here, 1 dozen, where the units of 12 is remaining constant, and the object is changing here. You can see, right? So the objects are changing here, but the units will not change. Object is changing. It can be book, it can be pen, it can be pencil or apple, whatever. Okay. So object ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ ನಮಗೆ change ಆಗ್ತಿದೆ, but the word doesn't change, right? But the word doesn't change, right?
Yes, sir.
Okay. So there is remaining constant here. ಅದೇ ರೀತಿ here the objective ಯಾವಾಗ when I'm talking about mole, here the objects can be anything, like it can be atom, it can be molecule, it can be electron or proton or neutron or any type of substance. It can also be an apple, it can also be books, whatever. But when I am talking about mole, I cannot talk about apples or books or whatever. So that is a different dimension. So here I want to know the number of protons or number of molecules or atoms, how much are is present. So that is what mole. Okay. So ಇಲ್ಲೇನಾಗುತ್ತೆ 1 mole ಅಂದಾಗ ನಮಗೆ see here, 1 mole ಅಂದಾಗ this remains constant here. Okay. ಹೇಗೆ 1 dozen ಅಲ್ಲಿ 12 ಅನ್ನೋದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆ, ಅದೇ ರೀತಿ 1 mole ಅಲ್ಲಿ 6.02 into 10 raised to 23 will remain constant. That is going to remain constant here. Okay. So here in case of mole, as I told, the objects can be atom, molecule, electron, proton, neutron, or any type of substance. classes that will be going to see that. So that is what the difference, or that's what you need to understand. What about a mole? Okay, and even we know that 12 AMU is equal to 1 carbon atom, right? So I can write like this: 12 AMU is equal to 1 carbon atom. So ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಿದ್ದಾರೆ, ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ದು ಮಾಸ್ ಎಷ್ಟಾಯ್ತು? That is 12 AMU. Okay, so if I am changing this 12 AM to 12 gram, I am converting AMU to 12 gram. That 12 gram is going to be the weight of 1 mole of carbon atom. Understand the difference here? Okay, so when I am expressing in terms of AMU, so AMU li express ಮಾಡಿದಾಗ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ ಎಷ್ಟು ಮಾಸ್ ಅಂದಾಗ that is going to be equal to 12 AMU, atomic mass unit, AMU. ಬಟ್ ಅದನ್ನೇ ನಾನು 12 ಗ್ರಾಮ್ ಅಂತ ಏನಾದರೂ ಬರೆದ್ರೆ, 12 gram ಅಂತ ಬರೆದ್ರೆ, that will indicate how much that is containing of 1 mole of carbon atom. So 1 mole is how much? 6.022 into 10 raised to 23 carbon atoms. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ ನಾನು ಹೇಳ್ತಾ ಇರೋದು? 12 ಗ್ರಾಮ್ ಅಂದ್ರೆ 6.022 23 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದೆಯಲ್ವಾ, ಅದಷ್ಟುದು ವೆಯ್ಟ್ ಎಷ್ಟಪ್ಪ ಅಂತ ನೀವು ಕೇಳಿದ್ರೆ ಅದೆಷ್ಟಾಗಿರ್ತದೆ? 12 ಗ್ರಾಮ್ ಆಗಿರ್ತದೆ. Are you getting what I'm saying? If you have any doubts, just ask me. ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಏನಾದ್ರು ಕೇಳಿ. Okay. We'll take one more example and we'll try to understand this. So let me take another example of N2. So that is, if molecules of or molecular mass of N2, molecular mass of N2 is how much? What is the molecular mass of N2? How much is the molecular mass of N2? How much is molecular mass?
14.
ಅದು atom.
14.
Atom ಆಯ್ತು.
15.
14 into
28.
28. Yes, 28. Yes. ಇದನ್ನ ನಾನು ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ರೆಸಿಂಗ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ 28 AMU. ಓಕೆ, ಸೊ ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಗುತ್ತೆ. ಯಾಕೆಂದ್ರೆ N2 is a molecular state. ಸೊ ಅದ್ರದ್ದು ಮಾಸ್ ಎಷ್ಟು ಅಂದ್ರೆ 28 AMU. ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾನೇನ್ ಹೇಳ್ತಿದ್ದೀನಿ, ಒಂದು N2 ಮಾಲಿಕ್ಯೂಲ್ ಮಾಸ್, ರಿಮೆಂಬರ್ ಒನ್ N2 ಮಾಲಿಕ್ಯೂಲ್, ಒಂದೇ ಒಂದು N2 ಮಾಲಿಕ್ಯೂಲ್ ಮಾಸ್ ಎಷ್ಟು 28 AMU ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಓಕೆ, if in that case, if I am going to consider 1 mole of N2 molecule, 1 mole of N2 molecule will be equal to how much now?
28 grams.
Exactly.
28 grams.
Yes. So now you got it. Okay. So ಈಗ 28 gram ಅಂತ ಬರೀತೀನಿ ನಾನು. Yes. Okay. So 28 gram is the 1 mole of N2. So therefore, how much 28 gram of N2 contains? How much it will contain?
12.044 into 10 to the power 23.
No, it will contain this much only. Okay, so it will contain this much only. Nan adane nimge helkondu bande. Object is changing here. Object will change, but the value, the number remains the constant. Okay, it can be any molecule, it can be any atom, it can be any electron, proton, whatever you take, the object changes. But the value of 1 more is 6.02 × 10⁻23 will not change. Right here? No. Is that clear to you all now? Yes. So new molecular adru tagobodu in terms of electron adru tagobodu in terms of proton, whatever you take, but it will always contain only this much number, that is Avogadro's number. Okay. So is that clear now? Okay. So that is about small little brief explanation to the mole. So we will see that what is there in this concept slowly. Okay. Okay. So before moving on to the next thing, we will just have a look on the video.
How do we calculate the mass of a single atom? Is it practically possible to do so? Is there any weighing balance designed to weigh the mass of a single atom? Let us now find out the answers to these questions. Imagine we have two objects A and B. Object A weighs around 12 kilograms is what we know. But we do not know the weight of object B, and that's what we need to find. How do we find that out? We just have a weighing balance with us. Let's put them on either side of the balance and see what happens. Clearly, object A is heavier. Now if we want to find the weight of B, we will need something smaller to compare it to. So let's say we cut object A into 6 equal pieces. And now we compare the weight of object B with one piece. We see that this piece is still heavier than the object B. This probably tells us that we need a smaller piece for comparison. So let's assume we cut object A into 12 equal pieces, which means each piece weighs 1 kilogram. And now when we place them on either side of the balance, we see that it's in equilibrium. Now can we tell the weight of the object B? Yes, each piece of object A here is 1 kilogram. And hence we can say that object B also weighs 1 kilogram. Let me ask you something now. Can we say that the mass of object B is 1/12 that of object A? That's correct. This is exactly how we estimate the atomic mass of an atom. Since we cannot directly calculate the mass of an atom, we usually calculate it with respect to the mass of a carbon atom. We take carbon-12 as our standard. Wait, what is carbon-12? What does it mean? The element carbon has many isotopes and the carbon-12 is one among them. And do we know what isotopes are? Well, for now, we need to understand that they are different forms of the same element. So in the case of carbon, we will have slight differences in the atoms, which is what makes them isotopes. So carbon-12 is one such isotope which is found almost everywhere in nature. Thus, an atom of carbon-12 is considered to be a standard unit and atomic mass is thus calculated with respect to one atomic unit. And how do we define one atomic unit? One atomic mass unit is defined as the mass unit exactly equal to 1/12 of the mass of a carbon-12 atom. So let us assume this is one atom of carbon-12. We divide this in 12 exact equal pieces. We take one piece from this out of the complete unit. Can we say the mass of this single piece is one atomic mass unit? Absolutely. And this is used as a standard to calculate the atomic mass of any other atom. Some examples of this would include the atomic mass unit of hydrogen being 1, carbon being 12, nitrogen being 14, oxygen being 16, and so on. How do we understand this in a simple way? Let me ask you a question. How do you measure the mass of a person? Using kilograms, right? We say that this person's mass is 50 kilograms. Similarly, we say that the atomic mass of oxygen is 16 atomic mass units or 16 AMU. This is how we measure the atomic mass of any atom. The units used are atomic mass units. But do we know what exactly gives the atom its mass? I mean, what exactly is responsible for giving the tiny atom some amount of weight? Let us know more about the concept of atomic mass in the next video.
Okay, so I think that video was informative. So it made you to understand more about AMU and what is atomic mass unit, all that things. So is there any doubts in that? Yeah. So hope is this clear for you all? Okay. So once after we discussed about AMU, that is atomic mass unit, and also after we discussed about the AMU, and mole, then comes on another concept with respect to mole. So that is going to be molar mass. Okay. So that is going to be molar mass. So what is molar mass? It is nothing but mass of a mole. How I am expressing the things in terms of gram. So that is, so molar mass of a substance in grams is equal to 1 mole of substance. So ಇಷ್ಟೊತ್ತರೆಗೂ ನಾವು ಏನ್ ಗ್ರಾಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಿದ್ವಿ ಅದನ್ನ ನಾವು ಮೋಲಾರ್ ಮಾಸ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ ಮೋಲಾರ್ ಮಾಸ್ ಅಂದ್ರೆ ಅದರಲ್ಲಿ 1 ಮೋಲ್ ಆಫ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಇರುತ್ತೆ, ಅದನ್ನ ನಾವು ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಗ್ರಾಮ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಹೇಗೆ AMU ನ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಿದ್ವಿ ಆ ತರ ಇಲ್ಲಿ ಮೋಲ್ ನ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಮೋಲಾರ್ ಮಾಸ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀವಿ. ಸೊ ಅವಾಗ ಅದು ಇಟ್ ಟರ್ನ್ಸ್ ಔಟ್ ಟು ಬಿ gram. Okay, so for example, if I take molecular mass of C2H6, if I take this one, and you all know how to calculate this one. So can anyone tell me what is the molecular mass of C2H6? Yes, that comes around 30, right?
30.
Yes. So 12 into 2 plus 6. So I can write this as a 30. What should be my unit now?
AMU.
AMU.
Absolutely. So that is AMU. Similarly, let me take how much now?
30 grams.
Yes. Yes. Okay. So this 30 gram is known as molar mass. And if I ask how much molecules of C2H6 is there in 30 gram, or how many molecules? Yes.
0.022 into 10 to the power.
0.022 into 10 to the power 23 mole. So
Yes, absolutely. Okay. So now you have got a clear picture, I guess. So ಯಾವುದನ್ನೇ ಆಗಲಿ ನಾವು in terms of mole ಅಲ್ಲಿ express ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದ್ರೆ, so that will contain always 6.02 23 entities. ಅದನ್ನ ನಾನು beginning ಅಲ್ಲಿ ಹೇಳಿದೆ ಅಲ್ವಾ? So ಅವಾಗಾದ್ರೂ number of entities ಆಗ್ಬೋದು. ಅವಾಗಾದ್ರೂ number of entities ಇದ್ರೆ ಅದನ್ನ ನಾವು mole ಅಂತ ಕರಿತೀವಿ. Hope I am making you people clear with this concept. So if anyone are not able to understand or any confusions are there, please let me know. Okay, so because this is very important concept. Iday concept nimge what your second year, first year ella competitive exam allu bari onde chapter alli barutte anta helangilla mole. The concept of moles is going to be applicable to many other chapters, especially physical chemistry. In that, especially when you're dealing problems related to problems, ನಮಗೆ ಇದು ಬೇಕಾಗುತ್ತೆ. So ಅದಕ್ಕೆ concepts are very important. Okay. So as I was saying, if we are expressing atomic mass of one atom, atomic mass of one atom ನ express ಮಾಡಬೇಕಾದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ ನ ಯಾವ್ದ್ರಲ್ಲಿ ಬರೀತೀವಿ ಯೂನಿಟ್? If you express atomic mass for one atom, so what is the unit then?
AMU.
Yes, that is going to be AMU. Same thing if I am expressing atomic mass for 1 mole.
Grams.
Yes.
Grams.
In grams. You can also even take in this order. For example, if I take 23 AMU is mass of 1 sodium atom. Okay, if I take 23 AMU is mass of 1 sodium atom, then 23 gram is mass of 23 sodium So either way is right. Okay. So 23 AMU is mass of one sodium atom, and 23 gram is mass of 6.02 into 10 raised to 23 atoms of sodium. Okay. I hope this concept is very clear for you people. So we'll just take one simple problem on this and we'll check how much you have understood. Right. So here Uday asked one question: how kg or gram convert into molar AMU? So if I have, let's say, 20 gram of sodium atom, if I have 23 gram of sodium atom, and it's clearly understood it consists of how much mole? Consists of 1 mole. Am I right? If in the same case, if I have 46 gram of sodium, then it is going to be 2 mole, right?
Yes, Anna.
That's it. So this is how you can convert in terms of gram to mole. Okay. And there are some formulas I'll be letting you know. So those kind of problems will be used. Okay. So, but we will not be talking the things in terms of kgs. So kg terms ಅಲ್ಲಿ ನಾವು ಜಾಸ್ತಿ ಮಾಡಕ್ಕೋಗಲ್ಲ. I will be handling it only gram. So I'll just give a simple problem. Calculate the number of atoms. Calculate the number of atoms of aluminium, that is Al. Aluminium in 10 gram. In 10 gram sample of aluminium. Can we try this one? So number of atoms of aluminium in 10 gram of sample of aluminium. Just try one. Okay. So we'll see. You try and we'll check. Now you need number of atoms. Just the atoms there. ಆಯ್ತಾ ಬರೋದು?
ಎಷ್ಟನ್ನ
We'll go through another one video.
In the previous part of the video, we saw that 1 mole of something is nothing but 6.022 times 10 raised to 23 particles. It could be atoms or molecules or anything. If I give you 1 mole of pure gold, then what will the number of atoms in it be equal to? Yes, these many atoms. And 1 mole of pure water will have these many molecules. But what is the scientific definition of a mole? Scientifically, 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon-12. Yes, even I didn't understand it when we read it for the first time. Let me break it down for you. Let me remove this definition from the screen. What we have on the screen now is 12 grams of carbon-12. Carbon-12 is one of the isotopes of carbon. Now 12 grams of carbon-12 is what was taken as a standard. What's so special about this? Can you guess the number of atoms here? Yes, it's 6.022 times 10 raised to 23 atoms. Now that you've understood this, let me repeat the definition for you. 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon-12. Did you understand the definition now? It consists of 2 simple parts actually. It tells us that this part is equal to this part. The number of particles in 1 mole of a substance is equal to the number of atoms in 12 grams of carbon-12. That's it. That's all the definition tells us. Many people get confused when it comes to the concept of mole. Let's take many more examples to be absolutely sure. How about taking the same example of pure gold and pure water? When we say 1 mole of pure gold, then according to our definition, it will have the same number of atoms as the number of atoms in 12 grams of carbon-12. That means 1 mole of gold will have 6.022 times 10 raised to 23 atoms of gold. Similarly, water will also have the same number of molecules as the number of atoms in 12 grams of carbon-12. That means it will have 6.022 times 10 raised to 23 molecules of water. Remember, the definition uses carbon-12 as a standard. It is used to compare the number of atoms or molecules or particles present in the substance. But what's the mystery behind this number? A scientist named Lorenzo Romano Amedeo Carlo Avogadro came up with this concept. I know the name is long, so we will address him as Avogadro. So the number 6.022 times 10 raised to 23 is called as the Avogadro's number. It is just a number used to represent quantities. It's similar to how we use the word pair for 2 or the word dozen to represent 12. Similarly, Avogadro's number is the term used to represent 6.022 times 10 raised to 23 number of any entity. So can we go to a shop and say, I want Avogadro's number of chocolates? Of course we can. The only problem is that the shop won't really have those many chocolates and neither will we be able to carry them back home. So getting back to the concept, Avogadro's number is just another number used to represent quantities. But the number is so huge that using this in daily life is not practically possible and advisable. Then why does the number exist if we do not use it? Yes, the number is not commonly used in daily life by us. However, it comes to the rescue of chemists that work with atoms, molecules, electrons, and many such small entities. That is the reason why it's used to calculate 1 mole of any substance. Let's talk about one last concept. We know that 1 mole of carbon-12 is 12 grams of carbon-12. That's because 12 grams of carbon-12 has the Avogadro's number of atoms. Now let me ask you a question. If you answer this correctly, it means you've understood the concept of mole. What will be the mass of 1 mole of pure gold? Will it be 12 grams? The answer is no. It will not be 12 grams. Note that in both cases, the number of atoms is the same, but the mass of an atom of gold is different from the mass of an atom of carbon-12. Hence, the mass of 1 mole of gold will definitely be different from the mass of 1 mole of carbon-12. So 1 mole of gold weighs around 196.97 grams. That is because mass of gold atom is different from the mass of carbon-12 atoms. Similarly, 1 mole of water will have the Avogadro's number of molecules, but it will not weigh 12 grams. So if we take 1 mole of water and find its mass, we get the answer as 18.015 grams of water. And I'm sure you know why. For the sake of comparison, if we take 1 mole of gold, 1 mole of silver and 1 mole of copper, then all of them will have the same number of atoms in them. That is 6.022 times 10 raised to 23 atoms. This number is the Avogadro's number. However, the mass of each one will be different. That's because the mass of individual atoms that make up these elements is different.
Okay, so is that clear to you all now? The mole concept is that clear? So the same concept we'll be discussing in your first year PU class. Okay. Okay, fine then. So I'll stop at this point. So we'll continue the remaining. We'll start up with a new concept in the next class. Okay, so try doing these problems. If not, you are not able to do, or just for the correction also, we'll try solving this in the next class. Okay. So thank you all. Have a good day.
Thank you, sir.
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 Thank you, Anna.